Tuesday, so I decided that we won't do MATLAB today. This session we're going to do sort of like a mini review. So for this session, ask me questions on homework for 11.1 and homework on the review problems that I gave you for the test. So if you have any. Are there any questions on the homework, first of all? 11.1?
Yeah, I had just a quick question. 11.1 isn't on tomorrow's exam?
11.1 is not on the exam. The material that you need to know for the test is only chapter 10. So 10.1 through 10.7. It's 5 questions long and an hour and 15 minutes. Any questions on 11.1? Yeah, we'll have class. On the homework?
Yeah, 21.
Okay, you're in the first edition, second edition? It said what? Yeah, I wouldn't really worry about that. Then I'd have to draw the contour graph. Don't worry about it.
Pretty well.
Something we can talk about in practice. Any other questions? Graphing domains, graphing functions. Well, graphing the graph was just like graphing surfaces, which we've done before, right? You simply replace the f of x plus y equals z. All right. So in general, you think, whenever you see f of x, y, you think z. So if you see that, you can sort of replace it. So if they say, graph the graph of this, it's the same as graphing the graph of this. Right? There's no difference. And what's that?
The top half of the cone.
Top part of a cone, yes. Right, so you see that you can look at this and you can notice the top part of a cone. You know what I noticed on the quizzes, grading the quizzes? People can't look at things and know if it's a line or not. Right? So like I asked for a plane and they give me the equation of a line. Right? So if I ask you for a plane and you give me something that looks like 1, 2, 3 plus t times, I don't know, 4, 5, 6, doesn't matter. Right? That's a line. You should know it's a line when you look at it. Right? So if I ask you for a plane and you write that down, it means you really have no idea what's going on. Right? It's just like me saying 3x plus 2 and you're telling me that's a problem. No, it's not. You should be able to look at it and know what it is. Right? Right? This is a cone. That's a line. This is also a line, but in 2D. In 3 dimensions, what is this? It's a plane. Okay. All right. Okay, I guess questions on the review problems. Right, so I posted those on my website, and it's from past finals, so I suppose we can go in order. Does anyone have any questions on Spring 205? Yeah? Okay, so question 2, we have lines with parent to equation, so it's not perpendicular to the plane. Oh, there it is. We have x equals 3 plus t, y equals 2 minus, is that a plus or a minus? That equals minus 1 minus 3. And this says that the plane is z equals x plus 2y. Okay, so this is a line, and that's a plane, and they said, part A, show that the line is not perpendicular to the plane. How do you show that? Of what?
The normal vector of the plane.
So the normal for the plane in this case is?
1, 2, minus 1.
And the direction vector for the line is?
1, 2, minus 3.
1, 2, minus 3. Since V is not parallel to N, it is not the line right? That's one way to do it. So we know to be perpendicular to a plane means to be parallel to its normal vector, right? These two clearly aren't parallel, right? Because to get the first two, you have to multiply by a constant 1, but then to get this, you have to multiply by 3. So there's no constant such that one vector is a constant multiple of the other, right? So it's not parallel, so it's not perpendicular to the plane. B says, still can't see it. Find the point of intersection. How do you find the point of intersection?
Plug in the X, Y, and Z values.
All right, take these guys and plug into that and solve for t, and then you plug the t back into here to find the points, right? So, the plane, you would have z is equal to minus 1 minus 3t equals x, 3 plus t plus 2 times y, which is 2 plus 2t. Okay. This means that t is what? Did anyone actually do it? Huh? Minus 1 was the answer? Okay, so if you plug in minus 1 here, that would give you 2 on this side. Just give you minus 1 here, would give you 2 on that side. Yeah, so t equals minus 1, and so this means x would be 3 minus 1, y would be 2 minus 2, z would be minus 1 minus 3 times minus 1, which is again 2. And so the point of intersection is 2, 0, 2. Right? That's what you guys thought? Yeah, so if you want to intersect a line with a plane, all you have to do is plug in the parameters for the line into the plane, solve for the parameter that works, and then use that parameter to figure out the point on the line. And that will be the intersecting point. Right? Because that's the t value where the line will hit the plane, right? Because we've let the x values, y's, and z's coincide. Part C. Find the symmetric form of the equation of the line which is perpendicular to the above plane and passes through the z-axis at z equals 1. Okay? How do you do that?
The line perpendicular to the plane will have a direction vector that's also perpendicular to the plane. So that would be
The normal. Right, so we know the direction vector for the line we're interested in is actually going to be the normal vector for the plane itself. Right? So that would be 1, 2, minus 1. And we know point. What's the point?
for 0, 0, 4.
0, 0, 1. Is that a 4 or 1? It's a 4. Right, so remember the axis for the equation of a line, what do you need? You need a point and a direction, right? The direction is going to be the normal vector because it's perpendicular to the plane. And the point, they said it passes the z-axis at 4, which means that x and y are 0 and the z is 4. So with that you can actually write down the line in x, y, z is equal to the point plus t times the direction. And they said write it in the symmetric form, right? So you can just review as well. Parametric would be what? X equals t, y equals 2t, z equals 4 minus t. And so after that, it's easy to go to the symmetric.
X minus 0 over 1.
Right, if you want to be pedantic about it, yes, x minus 0 over 1 equals
Y minus 0 over 2.
Y minus 0 over 2 equals Z minus 4 divided by minus 2. And that's the one there. Questions on this? Yes. No, because they specifically said it's on the z-axis, right? It said through the z-axis at z equals 4. So the z-axis is very specific. The z-axis is where x and y are 0. Right. So that's what specified that we had to choose that point. Yeah.
How do you know that the test vector is the normal?
Because we know the line is, it says the line which is perpendicular to the plane, right? So, right, so in a plane, the normal vector is perpendicular to the plane, right? So anything also perpendicular to the plane is necessarily parallel to that. And since it's a vector, we can actually use the same vectors. We can scale vectors anyhow we want, so I just use the exact same one. Other questions?
Exam, do we have to are we gonna have to sketch like only quadratic surfaces and cylinders or
Yeah, cylinders, quadratic surfaces, pretty much stuff like we did in class. There's not going to be anything crazy. Yes, and the exam, there's going to be space to show all your work, so you should, it's not like quiz where you just write down the answer. No, I'm actually going to grade step by step, so be sure to write everything out. Right. Other questions? All tests. Right, so quizzes I usually only mark the answers. On tests you're supposed to show everything.
It was fall 2005.
Fall 05.
Yeah. They didn't show us the solution in the website. So
Fall 2005. Problem what?
problem 1, yeah.
Problem 1. Okay, so it says for the curve given parametrically by that, compute the parametric equations of the tangent line at the point 0, 1, 1. Okay, so if a curve is given by r of t, then the tangent line at t equals t0 is, what was the tangent line?
R prime.
It's equal to r prime. R prime. What? R prime what? Of t? Of t0. R prime evaluated at the point. Plus? No, that's not R prime. R evaluated at the point, and R prime evaluated at the point is the direction vector, right? That's times t. Okay, so here what are we told? Here, R is equal to what? Sine of pi t, e to the t, and e to the minus t. Yes. And we know that our RT0 is the point 0, 1, 1. Okay. So this implies that our R prime of t is equal to
Pi
pi cosine pi t, e to the t minus e to the minus t. This actually means that t0 is equal to what? Correct? T is equal to 0. How do we know it's 0?
Because t initially equals 0, 1, 1, then RT to solve the t.
Right. So this gives you the x, y, and z coordinates, right? This is the position vector that gives you the points on the curve. So you want to know what t value makes the point be 0, 1, 1. So basically you're going to have to solve three equations. You want the x value, sine of pi t, to give you 0. You want e to the t to give you 1. You want e to the minus t to give you 1. Right? Solving those equations, t equals 0 solves all of them. Right? So t equals 0, we know it's the point you want to evaluate. Right? Which means I'm going to need to know what r prime of 0 is. Which is going to be what?
Pi 1 negative.
This means the tangent line is x, y, z equals the point, which we know is 0, 1, 1, plus t times the derivative evaluated at the t naught. And did they ask for it in a specific form? The parametric equations of the tangent line, right? So this means they want it in x equals pi t, y equals 1 plus t, z equals 1 minus t. Parametric equation. And that was part A. Any questions on part A? Right, so what you should know about tangent line is this fact, right? It's going to give you a point that you need to go through, and the direction vector is given by the derivative, just like how tangent lines back in Calc 1 and 2. To find the slope of the tangent line, you use the derivative. It's the same thing here, right? And the only catch is sometimes they won't tell you what the t naught is, but you sort of have to figure it out. If you know what the original vector function is, all you have to do is set each coordinate equal to what you need. Solve for the t that solves all of them, and that's the point you're going to evaluate the derivative at. Now let's look at part B. Compute all unit vectors normal to the plane that contains those 3 points and compute an equation of the plane. Okay, how do we start? Yeah?
Well, if you have 3 points, you can determine 2 vectors and find cross products on those vectors.
Right. So the picture here is we have a plane, there are 3 points in the plane. We have the point 0, 1, 1. We have the point 1, minus 1, 0. We have the point 1, 0, 2. Right, so we can actually determine 2 vectors. Let's say, for example, I want those 2 vectors. But really, any 2 vectors will work. So I can call this vector A, call this vector B. So in this case, A would be equal to, B would be equal to. A would be what?
1 minus 2 minus 1.
Right, you take the final points and you minus the initial coordinates, right? That's how we find vectors between 2 points. So it's 1 minus 0, minus 1 minus 1, 0 minus 1. Like this.
I have a question.
Yes.
It doesn't matter if we don't consider that one the final point. We consider 0, 1, 1 the final point and minus
Nope,
1.
it won't matter.
You'll just get the
Right, you'll just get the negative of the answer you're going to get, which it doesn't matter. You're going to take the positive and negative for this question anyway. And in general, it doesn't matter if you take the vector that's pointing this way or that way. Right? It still determines a direction of the thing. Yeah, so B in this case would be 1 minus 0, 0 minus 1, 2 minus 1. So your normal vector is the cross product of AB. Why is the cross product of AB?
Perpendicular to both.
Right, because the cross product gives you a vector that's orthogonal to the both vectors in the product, and that's what we want here. So this is going to be I, J, K, 1 minus 2 minus 1, 1 minus 1, 1. That's going to be minus 2 minus 1. This is going to be 1 plus 1, and then you make that negative. It's going to be minus 1 plus 2, 1. Right? And so now to find the, we can find the equation of the plane right away. That's actually second, sorry. Equation of the plane is, we can pick any point we want, any point you fancy. So you can pick this one, right? Use x0, y0, z0 equals 0, 1, 1, and n equals a, b, c equals minus 3, minus 2. What's the general equation of a plane?
K minus x minus xy plus b minus y. B times y is
So I asked this question on the quiz, and some people wrote the form, like ax plus by plus cz plus d equals 0. I mean, technically that is correct, and I gave you the point if you wrote that. But I would much prefer that you memorize this one because it gives you a lot more information and sort of tells you how you would find the equation of a plane, right? Sort of this one, it doesn't really say how you get that d, right? But this formula shows you exactly where the d comes from, right? So this times this plus this times that plus this times that, right? So it's better to memorize it in this form where you can know this is the point, that's the normal, I can actually create the vector, create the equation of the plane. This one is not as instructive, not as. I actually prefer to memorize it this way, in which case now we can see that the plane is minus 3, x minus 0, minus 2, y minus 1, plus 1, z minus 1. And that's good enough for the equation of the plane. And the unit vectors are going to be which guys?
It's going to be the unit vector of n and then the unit vector of negative n.
Yeah. So the unit vectors are this guy, u1, and u2 is just the negative. So u1 is equal to 2 minus 3 minus 2, 1 over the radical of 9 plus 4 plus 1 minus 3 minus 2, 1 over, that's radical 15. radical 14, which is not really a nice number. So that's one unit vector, and the second one is just the negative of that. Any questions? Okay, other questions? Other problems?
Can we review some of the concepts at the back?
The what?
On the review questions in the book?
What do you mean the concepts?
Well, they had review questions. Hang on, I'll read them.
But find somebody, I'll take a question in the meantime you're looking.
So
Yeah.
the problems on the exam, are they going to be like the problems on the review?
Yeah, they're going to look
just like
similar
five
to
of
this.
these?
Yeah, something like
Like these,
I mean, I might actually some general formulas, but
20,
other than
21,
that.
22. Everything up until there I understood, but then
Okay. So there are some review problems here. Like, what is a vector function, and how do you find its derivative and integral? You can answer that. Yeah.
I mean, you can write a vector function as a parametrization with each component, and to find the derivative, you take the derivative of each component, to find the integral, and take the integral of each component.
Right, so a vector function is a function that goes from Rn to the set of vectors. Right, so you can define how many variables you wanted. So you can say something like a vector function. I mean, you only deal with R2 and R3, so let me show you R2, for example. Right, so the vector function takes as input coordinates, right, the ones that we're studying, and outputs are vectors, right? So you have a vector function that says, a vector function in terms of the inputs coordinates is x and y, and it will output something like x plus y, 3 minus 2, 2x. Right? So that's a vector function. So here I'm taking the input as the coordinate, and then the output is a vector. Right? You call that a vector function. Right? And the second one is, what is the relationship between a vector function and a space curve? And of course, to take integral, you integrate each part, component. Derivative, you take the derivative of each component. Space curve, this is the same as a vector function with one parameter. Right? Because necessarily how many variables you have, you know, this is something like R of t is equal to x of t, y of t. Right? Where there's a single variable. The number of variables you have tells you what dimension the curve you're drawing is. So if you have one variable, you have a one-dimensional thing. Right? If you have two variables, you have a two-dimensional thing. So this vector function is actually describing a plane, right? Like a two-dimensional thing. This one describes a curve. So a space curve is just like a one-dimensional vector function. How do you find the tangent vector to a smooth curve?
Derivative?
Right, that's the unit tangent vector. So a tangent vector is just really just the derivative, right? But there's something called the unit tangent vector, which sometimes they like stating directions in terms of unit vectors. So. Right? And then this says, how do you find the tangent line? We actually did that already. And the unit tangent vector is that. Yeah.
Given two lines and we're asked to find the plane, do we just find the points?
Which two lines?
If we're just given the equations of two lines and we're asked to find the plane which those two lines are, do we just find three separate points and do the vector?
It depends on how the question is phrased. If the lines are parallel or not, it's actually a different approach.
Okay, I'm looking at spring 2007 1B.
So I can mention the approaches to you separately, right? So there might be one situation, situation one, where you have a plane and you have two lines in the plane, but they're not parallel. In that case, you can take the direction vectors for each of the lines, cross product them to get the normal, and then take a point on any one of the lines to get the point that you need. There's also the equation. There's also the situation where you have a plane, but you have two parallel lines. In which case, now the cross product thing won't work, right? Because you'd actually get the zero vector, right? Because the lines are parallel. The cross product of two parallel vectors is zero. So in that case, what you do is you find 2 points, a point on each line, create a vector with that, and then use the direction vector for one of the lines with the direction vector for that, and then proceed accordingly.
Could you do the second method in the first situation also if they weren't parallel?
You could, technically, you could do this and then find that vector and then cross product this. It would also work, but it's actually overkill here. It's more work than you have to do, right? Because just by looking at the equations, you'd see these two vectors pop out, right? There's no need to create another vector. Right? It's more computation, right? Here you don't really have a choice. Right? So the situations are different. The lines are not parallel, then cross product their direction vectors. It gives you the normal. Take a point on either line, and you're good to go. If they are parallel, you have to create another vector that's non-parallel, but still in the plane. So how you do that? Just take 2 points on each line. Yeah.
When two planes intersect, if you cross their normals, the vector that you get, is that always parallel to the intersection?
Yes, it's always parallel to the line of intersection. Right? So he's saying when you intersect two planes, is the cross product of their normals always the same as the direction of the line of intersection? And the answer is yes. And who can explain why?
Can you draw a picture of what you mean?
Like, I'm intersecting two planes. Right?
Okay, and the line.
He wants to know, how do you get this direction? Like, is it always going to be the cross product of the normals?
Because the normal is going to be parallel to the direction vector of the intersection.
No, it's not.
The normals are perpendicular, right? So the norm for this guy is going to be like this, right?
Right.
And the norm for this guy is going to be like that, right? Now it turns out, if I actually move N2 over here, when you cross product those, you get something perpendicular to both. Right? That's sort of what's happening. How do we know that that is perpendicular to both, though?
That's the normal.
But it doesn't have to be perpendicular, but
It has to be. It necessarily has to be. It has no choice. I'm asking why.
There's the normal picture is perpendicular to the plane.
The normal vectors are perpendicular to the plane, yes. So?
And they parallel to the other plane completely. Right?
So the line is on both planes and the normal.
The line is on both planes, meaning what relationship does it have with the plane?
Because any
Parallel.
approach is parallel to
Right. The line we're looking for has to be parallel to both planes, right? Because it's in both planes. which means it has to be perpendicular to both normals. And then you have to figure out how do you find a direction that's perpendicular to two other directions? Cross product. So yes, if you take the cross product of the two normals, you will always get a direction that's parallel to both planes at the same time.
But
Yes.
what if the line, instead of going this way, we're actually cutting across both planes that way? I mean, how do we know that the line is parallel to both planes?
Because
Unless
it's
it
in.
says.
It's a line of intersection. So we know the line is in both planes.
It doesn't matter the plane is perpendicular to each other.
Nope, doesn't matter.
If you they intersect, they will.
Yeah. Intersection means a set of points they share in common, right?
Yeah.
So if a line of intersection means it's a line that's in common to both planes, meaning the line is in both planes.
What if it were a point of intersection and not a line of intersection?
Two planes cannot intersect in a point. 3 can, yes. 2 planes cannot intersect at a point.
Well, actually, that goes back to the question we were working on before, which I didn't understand the approach. Given 2 planes and a point, I was told to find the plane of intersection at that point.
Right.
So how do 3 planes?
That's a completely different situation. So that's the situation where you're in. They say it contains a point and the line of intersection of 2 other planes. That's the question you're talking about, right?
It contained a point
Yeah.
and the equation of the plane of 2 other planes.
The line of intersection of 2 other planes. That was the first one,
Okay,
right?
right.
So here's the 2 other planes, right? And that's their line of intersection, right? And let's say here I have the other point, right? So basically what they're asking is they want a plane that contains that line and this point, right? So then you sort of imagine that after you find the equation of this, you sort of imagine that the planes aren't there anymore, right? So,
So
you
you're
just have
looking
that
for-
line and that point, and you want to find a plane that contains both, right? So they give you 2 planes, they intersected, so you can find this line. Well, that's just some random line in this other plane that I want to find. And then I want to make sure it contains this other point that they told me, right? So now how do I do that? Well, find a point on the line, make a vector, take its direction vector, and then I can cross product to get the normal. Yeah.
Find that point, you just set like x and y equals 0. And see
To find this point, yes. So it can be any point on the line, so the easiest way to do it is to find where it intersects one of the coordinate planes. So you can either set z equal to 0 in both equations, or y equal to 0 in both equations, or x equal to 0 in both equations, and solve for the remaining pair simultaneously. Okay, other questions?
Can you talk about something about like give you a plane and a point and find the distance between the plane and the point, or give you a line and a point, like the distance between them?
I don't think I asked a question on that, but there's a formula for it. We derived the formula. I was using scalar projection.
I find one of question in the review section.
So it was like we had the plane, and we had a point up here, right? Like P is equal to x1, y1, z1. We had the normal vector here, which can be A, B, C. And we've had another point in the plane, which we connected here. And so basically the distance between the point and the plane is just sort of the scalar projection of this. I'll call this vector, I don't know, D. Right, so the distance from the point to the plane would be equal to, you just want the magnitude of the component of B onto N. Right, that was sort of the setup. Right, but we actually know what that was What was that?
Use a vector and
Well, you know how to do it before.
done.
Right, so you can find any point in the plane and then connect it, make the vector here, and then do that for Other questions?
Spring 2010.
Spring 2010.
One key.
You said 1 part B. Okay, let's do that whole problem. So this actually asks you to find the line of intersection. And then we're going to do part B. So we have a plane that goes through 2, 1, 1, 1, 3, 1, 2, 1, 2. Q is actually the plane. Z equals x plus y. Okay, I want to find the line of intersection of these two planes.
The normal in the first plane and the normal in the second plane.
First you
Right.
find the
How do we
equation.
find the normal for the first one?
Cross two vectors.
Right, so we know about the plane P. It's sort of the situation we had before where there are 3 points in the plane. Right, we had that 2, -1, 1, 1, 3, 1. We had 2, 1, 2. We can create 2 vectors here. This would be the vector -1, 4, 0. This would be the vector 0, 2, and 1, right? And so the normal vector for P is actually going to be -1, 4, 0, 0, 2, 1, which is 4, comma, -1, which is 1, comma, -2. Right? Did you get that? Okay, so that's our normal vector for that. And now we know so the normal vector for P is actually 4, 1, -2. The normal vector for Q is what? 1, 1, -1. And so the direction vector for our line, remember this is the intersection, so we know that its direction is given by the cross product of the two normals, by the argument that we gave before. So that's -1 plus 2. This is -4 plus 2. 2. 4 minus 1 plus 2. Okay, so how do we find the line of intersection?
Take a point from the plane.
Take a point from,
Like any point with P.
is that good enough? Just take a point from P?
And then use the
No, it needs to satisfy both P and Q.
It has to satisfy both P and Q. So the issue is P can be this and Q can be the other plane going like that. Right? Where if this is P and that's Q, the point you pick could not be on the line. So picking a random point of P is not good enough.
would you set x equal to each other?
Right, so we need to, in order to do that though, we have to find the equation of P. So let's first find the equation of P. Now, P equals, how do I find the equation of P? Now I can pick a random point, right, and use this as the normal vector. So P is actually equation 4 x minus 2 plus y plus 1 minus 2 times z minus 1 equal to 0. So this I can get 4x minus 8 plus y plus 1 minus 2z plus 2 equals 0. And so here I would have 4x plus y minus 2z equals 2 plus that 5. So now how do you find a point on line of intersection? How do you get that? Yeah. Say the point in the xy plane. You can pick any point you want, which means that z equals 0. And so this means we have 4x plus y equals 5. This is from P. And from Q, we'd actually have x plus y equals 0. And so what I can do is I can actually subtract this. All right, I would have 3x equals 5. This is P minus Q. And so x would be 5 over 3. This would mean y would be minus 5 over 3. And I already know my z equals 0. So the point is 5 over 3 minus 5 over 3, 0. So line of intersection. And they said to parameterize it, right? So x would be this point plus what's the direction of our line? 1t. Y would be this point, and the direction of our line says 2t. And z would be 0 plus 3t. So that comes from here. This is the direction of the line. How do you find the intersection angle of two planes?
So we take the long part of the normal.
This is equal to the angle between their normals. Right? So that actually means, and we know how to find that angle, right? Theta would be cosine inverse of the normal for one, dot product with the normal for the other one, divided by the magnitude of the normals. cosine inverse of NP dot NQ is what?
4 plus 1 plus 2.
4 plus 1 plus 2 divided by the magnitude. What's the magnitude? 16 and 4, yeah, that's 21. And then the other one is square root of 3. So this is actually the cosine inverse of, that's actually 7 over, okay, so here's how we're going to do this now. 21 is 3 times 7, right? So this, I can actually write this as 9 radical 7.
How did you do that?
3 radicals. Right, because if I have radical of 21 times radical of 3, this is the same as 7 times 3 times radical of 3, which is the same as radical 7 times radical of 3 times radical of 3,
Okay.
which is radical 7 times 3.
No, it was the 9 I missed.
Yeah, because 3 times 3 was radical 9.
Right.
I thought this would have been a nice number that you can actually know when you're getting. So that guy is. Okay, so radical 7 over 3 is roughly how much? Oh no, radical minus. That's actually less than that.
It's not quite 1.
Yeah, it's not quite. So the cosine inverse for that would give me an angle in which quadrant?
First quadrant. Oh, wait. Would it? It's either the first or third.
It's like cosine.
It's either the first or the second, right? Remember,
I mean,
cosine
second.
works between 0 and pi. Right, so whichever angle puts me in the first quadrant, that's the smaller one. Whichever angle puts me in the second quadrant is the bigger one. That's basically what you have to figure out. I don't know why they'd ask a question like that, which they don't give you nice numbers.
So you just leave it like that.
Cosine, I'd leave it like
Would
that.
we have to figure out what quadrant it's in?
So, let's see. It's bigger than 1. So cosine inverse takes input between 0. Output is between 0 and pi.
Does it keep the answer like this?
What?
Do we keep the answer like this?
Well, that's one of the angles. So I just want to know, is the angle this or pi minus that? Those are the two options, right? I think it's a silly question. It's going to take a lot of guess and check. So, I mean, I don't really see the point. I mean, you could graph it and then you could say, well, here's approximately radical 7 over 3. I wouldn't worry about that. So that's how you find one angle. Let's take a 10-minute break and then we go to the other section.